So as you can tell, we're moving into lesson 5.2 now. We're moving on in our learning how to solve systems of equations. So far we've learned one way, and what is that way again? How do you know right now how to solve a system of equations? What method do you have in your toolbox now? Really? We don't remember.
It's the y minus y cubed.
Is it solving by graphing? Solving by graphing, and so we're looking to see, do they share any points in common? If they share any points in common, that would be considered a solution to the system. So far that's the only way we've learned. Now we're going to move into the algebraic way, because when we solve by graphing, the only way we can be certain that we have the correct solution is by substituting that into both of the equations and doing a check problem. Because we're really only estimating from a graph. But if we can, our estimate checks out in both of the equations, we can say it's a solution. Well, I want to start teaching you now how to solve algebraically. So our learning goal today is I can solve a system of equations using the substitution method, it's called. So there are two algebraic ways to solve them. Our first one being the substitution method. So here's what we're going to be doing with the substitution method. We are going to find the equation, at least when we start now. We're going to find the equation solved for either x or y. So we're going to look at the equations. Are either of them, or maybe even both, we never know, but are at least one of them solved for either x or for y? In other words, the x is by itself on one side, or the y is by itself on one side. Remember, we're not graphing, so it doesn't have to be y. It can be x now. Circle the expression. I want you to do that right there in those words. Circle the expression it is equal to. And then we're going to start now. We'll substitute the expression into the other equation. Really important that we don't keep working with that same equation. We're going to take something from one and substitute it into the other for that variable that it is the same as, and we're going to solve the equation. So basically I want to just stop right there and I want to set up some equivalencies and see why we can get away with this. So if I have the following two equations, 7 plus 2 equals 9, and then maybe I also have 9 equals 4 plus 5, is there any substituting that can go on here? In other words, we could set up another equivalency from some expressions in these that will still hold true. So since they're both equal to 9, shouldn't we be able to take this 7 plus 2 from the first one and put it in place of the 9 in the other one? Because that's what it says, 7 plus 2 is 9. So this is really, 7 plus 2 is really just another name for 9. I could put it in place of that 9 and I'd have 7 plus 2 equals 4 plus 5. Does the equivalency remain? Did we destroy the equivalency at all? No, because 7 plus 2 is 9, 4 plus 5 is 9. We still have an equivalency here. We still have 9 equals 9. So when we're substituting today, all we're doing is taking really something else that is equal to the same thing and putting it in its place. So after we do that substitution, the goal is, and if this doesn't happen, then your substitution isn't going very well. The goal is that one of the variables will no longer be there. It will no longer be in your equation. So you only have x's to solve for, or you only have y's to solve for. If you still have x's and y's in your new equivalency, that's a problem. You're not going to be able to solve that without graphing. And our goal today is to solve it without graphing. So after we do that, we're going to solve the equation for that variable, whether it's x or it's y, that is in there. Then we're going to substitute that solution, step 2, into the equation with the variable alone, because that would be the easiest one to use. In other words, we got to go and find the value of the other variable. And then step 3, we're going to do just like we did when we graphed. We're going to put our solutions for x and y into an ordered pair. From the graph, we got the x and y from the ordered pair where they intersected. Here we're going to get the x and the y and say, oh, this is where they would intersect on the graph. So if we solve the same system of equations by graphing, we should still get the same answer. Okay, so let's just start practicing. we have the system y equals negative x plus 5. We have x minus 4y equals 10. Remember what it says? Look for one of the equations to be solved for x or for y. So are either of our equations in that state? Do either of them have an x or a y alone? Yeah, which one? The top one does. The first of the two does. So we're going to circle the expression that it says that y is equal to. Y is the same as, they're saying in this situation, this is true. You can count on this. Y is the same as the opposite of x, or negative x, plus 5. So what we're going to do then, that means we are going to let that new name go into the other equation for that other y, for where the y is. Because it says y is negative x plus 5. So we should be able to substitute that in. It's another name for y right now. We should be able to substitute that into the other equation for our y. And we should only have x's now. So let's, step number 1 says, do the substitution. So we're going to take that x minus 4. We're going to substitute in the negative x plus 5 for the y. Everything else in that second equation stays the same. So step number 1, substitute the expression into the other equation for that variable and solve the equation. So we should be ready to solve this equation. Now, I'm going to insist, so that this will go well, I am going to insist we change any subtractions to add the opposite. So we have a subtraction right here. We're going to change it to add, and we are going to change 4 to its opposite. What is the opposite of 4? Negative 4. We don't have a subtraction going on in the parentheses, so nothing to change. Now we're ready to, well, it looks like we have to simplify this first before we can start solving it. So this x, is it part of the multiplication, this x out front? No, it's what I call a tag along. Just bring it down. And now we're going to do some simplifying. We're going to take the negative 4 times the negative x. We're going to take the negative 4 times the 5. So you with me? Let's do it. Negative 4 times negative x. 4x. A positive 4x, right? Bring down that plus sign that's in those parentheses. Negative 4 times 5.
Negative 20.
Negative 20. We're still not done simplifying because we now have x's on the same side of the equation. We're not ready to solve this yet. What can we simplify it to now? 5x plus negative 20 equals 10. Okay? We're finally actually done simplifying. That's all we've done so far. We substituted in, realized that we could do distributive property, had to do distributive property. Then we realized we had some like terms on the same side, so they're going to be put together. Now we're finally ready to start solving this. What are we going to do? Add 20. Add the opposite of that, negative 20. So now we have 5x alone over here, and on the other side we have 30. Next, divide by 5. And our x equals what?
6.
6. Okay, so x equals 6. So we have part of our solution, only part of it. Any questions on that part? Step 1, do the substitution, solve that equation. Okay, step 2 says, now go back and solve for the other variable using the equation that was, set equal to the single variable. It doesn't matter which one you use, by the way. You get to go back and you can use either equation. We'll substitute our x into it and we'll get our y value. But it makes a lot of sense to use the first one because we're looking for y anyway. So it says y equals. Well, it says take the opposite of x, add 5, you'll have the y. So we might as well use that equation. Y equals negative x plus 5. We could use the other one, Just gonna take us more work. So we're gonna substitute in, that negative sign is not part of the x, it's out front of it. It's like the opposite of, remember? And we're gonna substitute a 6 in for our x. So if that was a negative 6, we would be substituting in a negative 6 there. But it's a positive 6. So now we say, what is the opposite of 6? Negative 6. Negative 6 plus 5 is? Negative 1. We now have our y value. Step 3 says, write the solution as an ordered pair. So step 3, our solution is what? Ordered pair 6, because that's the x value we got, negative 1 because that's the y value. Not because that's the first one we solved for was 6, but because it actually was the x value, which is the first one part of our ordered pair. If we substituted this, I'm not going to, even if the instructions in your homework tell you to do check problems, I'm not going to make you do that. More importantly right now, is I'm discovering that you know what check problems do with students. They just want to get them done, and they pretend it's checking out. They don't really use them the way they should use them. So when you're ready to use check problems correctly, they're going to be quite useful to you. But some of you aren't figuring out what check problems are really about today. But that doesn't mean I'm always going to let you off the hook just because you guys are like that. It just means today I am letting you off the hook for check problems. I want your concentration to be trying to solve these. Now, when we start the homework, I'll check for you, but I think I gave you problems where you should always get integer x and y values. If you start getting fractions and decimals, that might be a good indication something's going wrong, okay? But I'll check it when we start the homework. Any questions on this one at all? No parts of this. Nothing. Okay, then let's go to the back side. Here's our other system we're going to solve. So we have the opposite of x, subtract y equals 10. We have x equals 3y minus 2. What would you do in this one? What would we do? We look for one of the equations to be solved for. Does that have to be solved for y? Can it be solved for x? Isn't that the case in our second equation here? Doesn't the second equation have the x alone? So it's saying another name for x is this, 3y minus 2. So you're going to need to write these equations down from the book first of all. Write your equations down. And then you're going to look to see, okay, are one of the equations solved for x or for y? I'm going to circle the expression that I can use for substituting. And when I substitute, I have to substitute into the other equation. I have to use the other equation, and I have to substitute in for what it's another name for. So we're going to have to substitute in for x. So step number 1, other equation, the opposite of, and we're going to put what we substitute in for x into parentheses. We have 3y minus 2. So we're substituting into this one right now, the top one. Subtract y equals 10. Well, there's some subtractions going on. What did I say we were going to do with subtractions? Add the opposite. So we got this subtraction in here that will change it to addition, and the opposite of 2 is? Negative 2. We have a subtraction going on here. Let's just change it also to add, and the opposite of a positive y is a negative y. In fact, we could even slip a 1 in there. It's like a negative 1y, isn't it? Now, look at our statement we have here now. Look at our equation we have here. Do we have both x's and y's? We just have, do you see any x's anymore in number 1? It's just y's. That's a good thing. That's what we want. We don't want there to be any, we can't have both variables involved or it's going to be trouble trying to solve it. So now, what is this opposite sign out front really the same as? Anybody know? What's another way we could look at that opposite of sign out front? Multiplying by a -1. So we could slip a 1 in there and say, we really have a -1 here that we're going to distribute. So we have -3y now, because -1 times +3, Chase, are you with us? Is -3y. Bring down the addition sign in our parentheses there. -1 times -2. 2 plus our -1y and our equals 10. We're still simplifying. We did distributive property to get rid of parentheses. Now we're going to do what? More simplifying, or are we ready to solve? Yeah, more simplifying to do, don't we? We have y's on the same side of the equation. So what can that become? -4y plus that 2. When everything's addition, you get to add in any order you want. So we're going to say, oh, there's that -3y, and the third term is a -1y. I'll bring them together and get a -4y. Bring my +2 along that doesn't have anything to be combined with. And my equals 10 down. Go ahead and solve that equation. Yes, Hayden.
I did it where we got -3y plus 2 minus y plus 10, and I subtracted the 2 right away.
You can do that. You can do it.
And
You
I
just-
got,
But then you're going to start solving, and then you're going to go back to simplifying. Is basically what's going to happen. So now you have,
well, I subtracted 2, and then I got -3y minus y equals 8. And then I got -4y equals 8, and then divided.
and we're going to get the same thing,
Yeah.
right?
Just wondering.
Yep, you can do that. Yep, it's okay. So we got -4y equals 8 now, because now we're starting to solve. So in fact, I should just go back to, I like to kind of make it look like, when are we starting to solve? We're starting to solve right there. We're subtracting 2 from both sides, so now we have -4y equals 8. And now we will divide both sides by -4. And we're going to find that our y value is what?
-2.
-2. Okay? Are we done?
No, you're fine.
Now we're going to go find our x value. So step number 2 says, okay, go find the x value. Doesn't matter which equation we use, really? No, it doesn't matter. You get to use either one. Which one makes more sense to use in this situation? The bottom one, because it's x that we are trying to find anyway, so it says, here's how you can get x. Take 3 times the y value and subtract 2. So we're going to substitute our y value in and do exactly that. So x equals, what's 3 times a -2? -6. Subtract 2. What's our x value, Colin? You appear to be done, so you must have this. Oh, you're not. Okay. Taking a little break. What is our x value, Chase? -8. So now we can say, oh, step 3 says, I now know my solution. I know where these 2 lines would intersect on the graph. Where would they intersect at? -8, -2. So if we solve it by graphing, we get the same solution. Now we're solving algebraically. So for those of you who don't like graphing, hopefully you'll like the algebra. You're going to do that. Okay, questions on that one? Other than the one I had. Okay, then let's go do the other thing that we're going to do. We're going to set up our own system of equations. Sum of 2 numbers is 75. Sum meaning what? Yeah, the answer you get after you do an addition. The second number is 3 less than twice the first. Oh my goodness, that sounds like, my aunt is related to your cousin who's married to, no. Let's just, take this and sort it out slowly here. What are the 2 numbers? So remember, whenever we do a word problem, we're always going to describe
X and Y.
Thank you very much.
I just guessed.
Because when we look at your equations, we should be able to make sense of, did they set up a good equation then, according to what they say x is in this equation and what y is. So we got two numbers, and they refer to them as a second number and a first number. So let's just stay with that. I mean, you know, we don't know what they are. So let's say that x is the first number just because it comes first in the alphabet before y. So x is the first number, and it, by the way, it does not matter. You get to choose. Either way, we should still get the same answers. We should still come up with our two numbers. And then y is the second number. And we need at least two equations to be able to set up a system of equations. And I'm going to be nice to you for a while anyway and tell you that when you have to set up your own, it's probably most likely going to be two usually. So we need two equations. What kind of information did they give us that could help us set up one of them?
X plus y equals 2. Wait, no. Yeah, x plus y equals 75.
Yeah, the sum of the two numbers. This sentence right here is one of your equations. The sum of the two numbers is 75. So our first equation could be x plus y. The two numbers, the first and the second number, should add up to 75. Okay? How about the other one? I'm going to guess the next sentence will take care of that. The second number is 3 less than twice the first. Go ahead, try to set up the equation for that. See how it goes. The second number is 3 less than twice the first. Second number is, usually you can just kind of like follow the words. Second number is 3 less than twice the first. Who thinks they got something for us? Who's the brave soul on a Monday morning that rejuvenated their brain when we really got lots of sleep? Maybe that didn't happen. Natalie.
Y equals 2x minus 3.
I'll write it down first, the way you said it. Is that what you said? Okay. So, how many of you agree with Natalie that this could be a good replacement for that sentence? The second number is y equals 3 less than, that means 3 needs to get subtracted from something, twice the first, 2 times x, the first number. Looks like a good equation. Y equals 2x minus 3. Good job. Okay, now we're ready to do our deciding, are either of them solved for x or for y? Bottom one is, it says y is 2x minus 3. Y is 2x minus 3. Y is the same as, so go ahead, it says, and put me into the other equation for the y. So step number 1, we're going to put in place of that y. Remember how I said we're just going to use parentheses all the time to make sure? Sometimes they're going to be really critical, and other times they're going to be kind of like just an extra lead used up. Are they critical this time? Are they critical this time? Is there a subtraction going on here? If there was a subtraction going on, they would be critical. Since there's addition going on, it's not. Is there any multiplication going on? No. So there is. What's it really being multiplied by? 1. When you multiply by 1, does that change anything? No. So in reality, we could just ditch these parentheses. They weren't playing a very critical role in this one because of the addition, because it wasn't being multiplied by anything other than 1. So now we got another simplifying step we can do, which is what?
X plus 2x.
Yeah, add these guys together. They're on the same side. Okay, go ahead and finish this problem. Step 1, it looks like we're going to get a value for x. Step 2, go find the value for y. Step 3, say, this time we're not going to write an ordered pair. We're going to write it, we're going to say the two numbers are. Monday morning, I gotta use my calculator, cause you know, that's a really huge number I gotta divide into there. I probably could have, I should have made myself do it, yeah. Keep going, guys. Step number 2 is what? What are you doing, step number 2 now? Now we gotta go solve for the y value. Don't give up yet, you're not done. Am I really hearing a calculator again? Oh, goodness. And when it is a word problem, we're going to say, we're going to write a sentence. The two numbers are what are our two numbers? Ben?
26, 49.
Yeah, are 26 and 49. Or 49 and 26. Now, depending on what you let x represent, what you let y represent, if somebody else would have said, I'm going to let x be the second number, and I'm going to let y be the first number, then you might have been solving for the 49 before the 26. It doesn't matter. The two numbers are, do they add up to 75, by the way? Yeah. And then it said that the one of them is 3 less than twice the other. Well, we're going to have to take 2 times the smaller one, aren't we? What's 2 times 26? Well,
52.
yeah, we just did it here. And then 3 less than that is 49. So yeah, so we have, here's a good answer. Okay, any questions on this one? Okay, I want you to get out a sheet of loose leaf paper, write down your heading for the assignment.